All right, so today we're going to dive deep into something that's super fundamental in Java, variable and constant declarations. And, if you're prepping for a senior software engineer interview, you might think, oh, this is basic stuff. But honestly, truly understanding this, it's a sign of a really strong programmer. You know what I mean? It can reveal a lot about how deeply you understand the language.
Yeah, for sure. When you're going for a senior role, it's not enough to just be able to write the code. Interviewers, they want to see that you get the impact of your choices. Things like how easy it is to maintain the code, even how it affects concurrency.
Exactly. It's all about the why, right? Why do we do things this way?
Absolutely. So today we're going to go beyond just the surface. We'll dig into the nuances, the best practices, and why they matter. Really get to the heart of what a senior dev needs to know about declaring variables and constants.
Perfect. So let's kick things off with a simple example, like, the classic int total is 0 kind of thing.
Right, that's the starting point for everyone. But even here, there are things to think about from a senior perspective. Like, did you know you can declare multiple variables on one line? Like int total equals 0,
Yeah.
count. Totally valid code, but what do you think about that, like from a code review standpoint?
Yeah. I mean, the compiler doesn't care, but if I saw that in a code review, I'd probably raise an eyebrow. You know? For me, it just makes the code harder to read.
Right.
Putting each variable on its own line, it just makes things so much cleaner and easier to understand.
You're absolutely right. And when you're a senior developer, you're not just thinking about yourself, right? You got to think about the whole team, the long-term health of the code. Clear, readable code is so important for that.
Absolutely. And don't forget, it also makes it easier to add comments.
Oh, yeah, for sure. Comments are vital for maintainability. And, in some super rare performance critical situations, separate lines can actually help the JIT compiler. But honestly, human readability, that's the top priority.
Agreed. Making the code a tiny bit faster is not worth sacrificing readability for most of the time. Now, let's move on to object creation. Something like random generator equals new random.
Yeah.
What's the key takeaway here for someone aiming for a senior position, especially when they see random twice?
That's a great point. What we're seeing here is Java's strong typing system at work. The first random, that's declaring the type of the variable, we're saying, hey, this variable generator, it's going to hold a random object. The second random is the constructor. That's where we use new to actually create a new random object in memory.
So it's like we're first saying what it is, and then we're actually making it.
Exactly. It's like you have a blueprint for a house, and then you actually build a house based on that blueprint. The blueprint is the type, the house is the object.
Makes sense. Now, what about the var keyword? Newer versions of Java let you write var generator, new random interrupt. What are the trade-offs a senior dev should think about when deciding whether to use var or be explicit about the type?
Yeah, that's a good one. var is all about conciseness. If the type is obvious from what you're assigning, you can save some typing. Like in our random example, it's pretty clear. But a senior developer needs to think about the team, the whole code base. Will using var everywhere make it harder for others to understand what's going on?
Especially with more complex stuff, right? If you're using var all over the place, it might be harder to figure out the type of a variable without really digging in. And that can make the code harder to read and maintain.
You got it. And think about things like IDE autocompletion and compiler errors. Sometimes being explicit about the type can help those tools do their job better.
Right, the IDE can give you better suggestions, and the compiler errors might be more helpful.
Yeah.
It's a balancing act, right? You want to write less code, but you also want it to be clear and maintainable for the whole team.
Exactly. At a senior level, you're not just coding for yourself. You're a leader. You're setting the standards for the whole team.
Okay, let's talk identifiers. Those are the names we give to our variables, right? We know the basic rules. Got to start with a letter. Can use letters, digits, underscores, and even dollar signs. But we also know that using dollar signs is generally a no-no. Why is that?
The $, it has a special meaning in Java. It's usually used by the compiler and other tools for names they generate. If you start using it in your own code, it can get really confusing. It's like, is this a name I made, or did the compiler make it? And that can lead to problems.
Yeah, you don't want to mix those up. It's about following the conventions, the standards that everyone in the Java world understands.
Right. When everyone follows the same conventions, the code becomes more predictable, easier to understand. It's all about making life easier for everyone who works on the code.
Now, what about using, like, non-English letters? Java supports Unicode, so technically you could name a variable using Greek letters or whatever, but should you?
Technically you can, yeah, but practically, Probably not the best idea. Think about keyboards, IDEs, and especially teams with people from different countries. It can just create a lot of unnecessary confusion and headaches.
Right. You want the code to be clear and accessible to everyone, no matter what language they speak or what kind of computer they use.
Exactly. Stick to the basics, standard English letters and numbers. That's the safest and most sensible approach.
Okay, and just a quick reminder, Java is case sensitive. My variable and my variable, those are two different things. And of course, no spaces or keywords in your identifiers. Let's talk about naming conventions. Lowercase for variables and methods, uppercase for classes and interfaces, camel case for multi-word names. Why are these so important for senior devs to not only follow but also to enforce?
These conventions, they're not just about style, they actually help you understand the code. When you see a name starting with a capital letter, you know it's a class. Lowercase, probably a variable or a method. Camel case makes multi-word names easier to read. It's all about making the code clear and easy to understand at a glance.
Right, it's like a visual language, right? You see a certain pattern, and you instantly know what kind of thing you're looking at.
Exactly. And when everyone follows these conventions, the code becomes consistent and predictable. It's like you can open any file in the project and immediately know what's going on. And that's huge for maintainability, especially in large projects.
Okay, let's move on to initialization. One thing that's really emphasized is that you have to initialize local variables before you use them. Otherwise, boom, compiler error. For a senior dev, understanding why this rule exists is super important, not just knowing the rule itself.
You got it. At the core of it, when you declare a local variable, you're basically reserving a little space in memory to hold its value. But until you actually put something in that space, it's just garbage data. It could be anything. So if you try to use the variable before you initialize it, you're basically playing roulette with your program. You have no idea what's going to happen.
That's where the Java compiler comes in with its static analysis, right?
Right. The compiler is smart enough to look at your code and say, hey, wait a minute, you're trying to use this variable, but you never gave it a value. It's like a safety net that catches potential bugs before they even have a chance to cause trouble.
I see. And what about those tricky scenarios with if-else blocks, where it looks like the variable is always initialized, but the compiler still complains? What's the deal with that?
That's a great example of how strict the compiler is. It doesn't just assume everything is fine based on what we think is obvious. It needs absolute certainty. It needs to know that no matter what path the code takes, that variable will always have a value before it's used.
Ah, so even if we think, oh, it'll always get initialized in either the if or the else block, the compiler isn't taking any chances. What if neither block runs?
Exactly. It's all about being rigorous and making sure there are no loopholes. And this kind of thinking, being really precise and careful, it's a hallmark of a senior developer.
It's like defensive programming, right? Anticipating all the ways things could go wrong and preventing them ahead of time.
You got it. Now let's talk about declaring variables as late as possible right before they're used. Why is this good practice, especially in those long, complex methods that senior devs often work on?
Yeah, that's an interesting one. I guess it keeps things tidy, right?
More than just tidy. When you declare a variable right before you use it, it's super clear what that variable is for and how it's being used. You don't have to scroll up 100 lines to figure out where it came from or what it's supposed to be.
It's all about keeping the code easy to understand.
Yeah.
Right? Reducing the mental effort needed to follow what's going on.
Absolutely. And it helps prevent mistakes, too. If a variable is only visible in a small section of code, you're less likely to accidentally use it in the wrong place or before it's been properly initialized.
Okay, I see. So it's about clarity, reducing errors, and making the code easier to maintain. All good things, especially for senior devs working on complex systems. All right, let's switch gears and talk about constants. These are declared using the final keyword, and it means the value can't be changed once it's set. Why is this immutability concept so important, especially for senior devs who are often dealing with concurrency?
Immutability is all about predictability and safety. When you have an immutable object or a variable that can't change, multiple threads can access it at the same time without stepping on each other's toes.
Oh, because if it can't change, there's no risk of one thread messing it up while another thread is using it.
Exactly. It eliminates a whole class of potential problems that can make concurrent programming a real nightmare. And it also makes the code easier to reason about. You know that once a final variable is set, that's its value for good.
No surprises, which is always nice. And besides concurrency, using named constants instead of just throwing in magic numbers also makes the code much more readable.
Totally. Like instead of seeing some random number like 3.14159 in the code, you see math.pi. Immediately, you know what it is. No more guessing games. It makes the code self-documenting, which is a huge win for maintainability.
Okay, the material makes a distinction between final variables declared inside a method and static final constants declared outside a method. Can you break that down for us?
Sure. A final variable declared inside a method that's local, it only exists within that method, and once you set it, you can't change it within that method. A static final constant, on the other hand, it belongs to the entire class. There's only one copy of it, and all objects of that class share it.
So static final is for constants that are like universal to the whole class, right? Like math.pi or calendar.days per week.
Exactly. They're the big fundamental constants that everyone needs to know about, and you access them directly using the class name.
Got it. Now, there's this odd thing about System.out, which is declared as public static final print stream out. But out isn't in all caps, which is the usual convention for constants. Any idea why?
That's a fun little quirk of Java history. Back in the old days when Java was first being made, the convention for constant names wasn't as strict. And System.out is like a super core part of Java. Changing it now would break tons of code out there in the world.
So it's like a grandfathered-in exception. They can't change it now because it would cause too much chaos.
Exactly. A little reminder that even in software, sometimes the past has a way of sticking around.
Okay, last thing on constants. The material talks about deferred initialization of final variables. That's where you declare a final variable, but you don't immediately assign it a value. When would a senior dev use this? And what are the gotchas?
You might do this when the value of the constant depends on something that happens at runtime. Like maybe you need some information from a configuration file or from user input to calculate the final value.
So you're saying, hey, this is going to be a constant, but I don't know the exact value yet. I'll figure it out later.
Exactly. But the key thing is you still have to assign a value to that final variable exactly once, and it has to happen before the variable is used anywhere in the code.
Okay, so it's like you're buying yourself some time, but you can't forget to actually set the value, and the compiler will still make sure you follow the rules.
Right. It's a powerful technique, but it requires careful planning and attention to detail. You don't want to end up with a final variable that never gets initialized.
So it's like a loaded gun, right? Powerful, but potentially dangerous if you don't handle it carefully.
Exactly. All right, last but not least, let's touch on enums. How do they relate to constants, and why should senior devs know about them?
Yeah, enums are interesting. They seem to be a bit more than just simple constants.
Enums are a way to define a set of related constants. Like, imagine the days of the week. Instead of using a bunch of separate static final int constants, you can create an enum called day and list all the days as members.
Wow. So it's like a group of constants that belong together, like a family.
Exactly. And enums have some cool advantages, like they're type safe, meaning you can only assign valid enum values to a variable of that enum type. It's like a built-in safety mechanism. And enums can also have methods and fields, which makes them even more powerful.
So they're not just dumb values, right?
Yeah.
They can have behavior and data associated with them. That seems pretty powerful.
They are. Enums are a great way to model certain types of data in a clear and structured way, and they're definitely something senior devs should have in their tool docs.
Wow. This has been a deep dive indeed. I mean, who knew there was so much to talk about with variable and constant declarations? It seems like such a basic thing, but there's a lot going on under the hood.
Absolutely. And for anyone out there preparing for a senior tech interview, I can't emphasize enough how important it is to really understand these concepts. It shows that you're not just a code monkey, you're a thinker, a problem solver.
You're someone who understands the why, not just the how.
Exactly.
So for all you listeners gearing up for your interviews, here are some questions to ponder. How would you explain the trade-offs between using explicit types and the var keyword in different team situations? What are the things you would consider? And can you remember a time when you encountered a tricky bug related to variable initialization or scope? How did you go about debugging it? And what did you learn from the experience?
Those are great questions. Being able to think through those kinds of scenarios and articulate your thought process, that's gold in an interview.
Because at the end of the day, it's not just about writing code that works. It's about building robust, reliable, maintainable systems. That's what senior engineers do.
Couldn't have said it better myself.
Well, thanks for taking this deep dive with us. It's been a pleasure.
The pleasure was all mine.
Until next time. Happy coding, everyone.